So, hi everyone, we are group president. We are a group of three. I'm Li Renpang. We are Hong Zhengxu and Yi Xiaohong. So, imagine sometimes you may want to have a quick sense about if an item can fit the surroundings before buying it, or sometimes you want to quickly measure the dimension of physical objects, but you do not have such a tools on hand. So, the goal of our project is to let people to use their cell phone to solve these problems. Our app allows users to position the imported virtual 3D object into the real world and to measure the distance between 2 points. Also, our app allows users to quickly construct and export a 3D object by their phones. Now my colleague Chris will show you a live demo. Chris.
So if we thinking about this situation, we move to a new place and you want to know how it's gonna look like when you add new furniture to it, and you need to start to measure it. So that's a little balcony I got, and I kind of want to make it a little cozy spot where I can read a book and have coffee. So maybe you start with here. You can see that's 50 centimeter roughly. If I want to put a bookshelf here, that's 93. So I can pick a big small one, like a table, but no chair. So I started by adding some models. So if we visit this website, so we build our own fake furniture store. So imagine if you have an online store that has the files when they are when there's a display. So the big bookcase is a little bit too big. It's not gonna fit. But the smaller one should be fun. And I can download this chair, plants, why not? The Linux decoration, I really like that, but there's no model, so guess we can build for ourselves. So if we go back to this and import it, import model, and everything should be in a folder called download. Here. You can see only the object file are marked white, and that's all you can select from. You import another model. So download the chair. And the last one, the plant. And now you can use draw function to draw the inner circle. So starting with adding a cube, and you can modify the dimension. So 0.1, 0.1. Right now I'm trying to get 2 legs. So click on this, you resize. Oh, messed up. You click the reset, it's gonna save you. And another cube, resize. That's a leg. And start to build the body. And add a cube, resize. Another cube, resize. Another cube, resize. Now we need to build the head of it. So I know it should be a square head, but just because we can, why not add a sphere head? We resize it, and we click on place it. So that's gonna bring us to the place it function. So right now we scan this area. The bookshelf is gonna go here. It's gonna fit like perfectly. And I can add a chair over here. So I don't have to stand up for the coffee and the books. I can even do this. The table, I can put coffee here. I can put a plant over here. For the Linux suite we just built in, we can place it right here just because I like it. And we have some pre-built models in the app, so we can add a wooden stove over here. And that's how the final look is gonna be like. And thanks, that's for the demo. I'm gonna leave this to Felix.
Thank you. So, so this is the structure of our application. The heart of our application is the AR Core software development kit, which provides a service needed to build the augmented reality. And to build the AR scene, the AR Core takes 2 major inputs. One is the image and the sensor signal collected from the camera and the inertial measurement unit equipped on the smartphone. And the second is the converted 3D file, which can be either from OBJ file stored in external storage or the user sketch 3D objects. And in the AR displayed scene, the user will be able to manipulate and interact with the objects. And these kind of gestures will be captured by these input detection and interpretation units and interpreted as the commands to rebuild this AR scene. And as for the future work, the team is aiming to work on two major aspects. One is to improve the UI, and the second is to improve the model importing processes, such as adding textures to the imported model, and also like switch the loading process to asynchronous one to reduce the waiting time for the rendering, and also support more types of 3D files other than OBJ files.
Okay, so we've learned a lot during the project implementation. First, we learned that we should do more investigation before estimating the workload. While we're deciding the spiral goals, we underestimate the difficulties of importing and rendering external 3D model files. We should it should not be that hard, but implementing this feature in Unity is very difficult because we have to simulate Unity's compiling process. We also underestimate the difficulties of constructing 3D models. Since AR Core does not provide such an API as in its Unity version, we have to implement it in Unity from scratch. In addition, we found that using Unity to develop mobile application is very difficult. Since Unity is optimized for game development, it lacks lots of basic support for app development. For instance, implementing a quick listener in Unity is way harder than implemented in Android. Certain cross-platform frameworks like Flutter could be a better option to develop a cross-platform apps. Lastly, Unity's AR Core is hard to recompile to run on iOS device, as it requires ARKit support from Apple. And that's all we learned in this project. And that's it. Thank you so much.
Great, thank you. I'll give you some applause there. Good demo. It's great to see all those things come together, the import and the drawing. I only have really one question, maybe two. When you were drawing that Inukshuk, it looked like a 2D drawing, and yet somehow when it came out, sorry, it was 3D. So can you explain that? Like where?
Yeah, sure. Just let me share my screen again. So, just a second. I disconnected from the Zoom meeting, so just let me join back in. And if I share my phone screen, so right now I should be able to see my phone screen, right?
Yep.
So there's a place that if I skip, actually, let's just go back to.
You're trying to answer. You are trying to answer my question, right? That why?
Yes. So let's see if we add a cube and add a sphere like this, and we have the rotation button on the. You can see on the bottom left, there's a horizontal rotation, and you can do this.
I see, but it's only. Oh, I see. That's just the way you showed it.
It is more obvious, but when I'm trying to build a model, I'm trying to be quick, so I don't lose everyone's attention.
Okay,
and
that's great.
I'm trying to do it quick.
Yep, I got it. Thank you.
I tried not to rotate it because I only press the reset button because that's going to save us some time.
So I think you've answered my question. Thank you. And it's, if you can stop sharing and maybe on the structure, it's a good global picture of the structure. Could you bring that picture back if someone who has it?
The global picture?
You mean the structure of the application?
Yeah. Could you just go back to that? It's a good global picture, but I'm still struggling to see which of these things is software that you wrote, like in the AR Core block there. What did you write inside that block?
So I can share my computers. Actually, can I just show my computer screen?
Yeah.
Okay,
you can,
so
share the screen, but it's a verbal answer I'm looking for, not.
Yeah. So if we look over here, so for the AR Core, we didn't do much with it.
So for the all the feature point, all the cloud feature feature points, all the recognition, we didn't do much about it. But for the rest, seeing
maybe just I'll just interrupt you. So that block that you're talking about, AR core, you're saying you didn't write much code inside that. Is that?
So, but everything other than AR core is all implemented by ourselves. So we have to
Yeah, AR core is the API provided from Google. We use that and to implement everything.
But inside that block, the thing that's rendering and doing all the 3D stuff is AR core. I think I understand. Dan, do you have any questions?
No questions. I just wanted to say good work, guys.
Thanks.
Great. Kia, questions?
No, same for me. Good job.
All right, well done.